Great. Thank you guys for joining us, and thank you for your commitment to this training. I can see that the techie guys are the ones that wait till the end. It's like in the first day, many people join, then less people in the second day, less people in the third day. But at least that's what we aim for. This training is designed for technical people mostly, and we wanted some pre-sales team to join, but it's mainly for technical people. So we're happy, guys, to see you again. I want to remind you that after the end of this training, we will be uploading those videos to our YouTube channel. I'll send it to you by email so that you can go and watch it, so they can watch it over and over. They're very useful sessions. In addition to that, I will get the documents from Broadcom team as PDF files, and also I'll share it with you by email so that you can benefit from these great presentations. We're in a good position to start, so I'll leave it to you, Kamran. Please go ahead.
Sure. Okay. So once again, welcome. Ahlan wa sahlan, everybody. It's good to see so many of you turned up on day 3. As Mohit was saying, we were expecting that by day 3 there will be relatively less people, which happens in all of these type of trainings. It shows your commitment, and I think it also should give you this encouragement that you are the guys who have the tenacity to go till the end, right? So this is good.
I have like a request from Ramzi. He wants to talk. Come on, Ramzi. I'm gonna allow you to talk. I'll be happy to get you engaged, guys. You're okay with that? Come on. He raised his hand.
Could you say again? Sorry.
One of the gentlemen joining now, he's raising hands. He wants to say something, so I'm gonna allow you to talk. Go ahead, please, Ramzi.
Anytime.
Just unmute yourself, Ramzi. Go ahead, please. Go ahead.
Can you hear me?
Yes, we can hear you.
Okay, great. I just have a couple of questions before we start, if we may ask them.
Yes,
of course.
Okay. Can we please revisit the difference between the community and the enterprise SONiC? I mean, what is the real difference between the community and the enterprise version of SONiC? And the second question is, my understanding is SONiC does not support stacking. This is what we were discussing yesterday. So what is the alternative way to stack two switches using SONiC?
Okay, sure. So in terms of the what is the difference between community and enterprise SONiC distribution by Broadcom? So there's a little bit of background noise from somebody. If you could go back on mute. Yeah, thank you. So the difference is the enterprise distribution of SONiC by Broadcom. It is a commercial distribution of SONiC, which is a licensed product. So if anybody wants to deploy our distribution, it is a licensed product which comes with full support from Broadcom. Whereas the community SONiC is, as the name suggests, is open to community. Anybody can download, anybody can compile even different parts or different versions of different containers and compile their own software. There is no fee involved, but at the same time, then there is no committed support with the community SONiC. So enterprise SONiC distribution by Broadcom is like a packaged software, and it comes with enterprise class features and full support. Now, what we do at Broadcom, as I mentioned, that when we create new features, we upstream them as well, right? So anything that we are creating, it will also be available in community SONiC after some time. There is no intention for Broadcom to take you to an island where you are like tied to this enterprise distribution and you cannot move away. This will be opposite to the overall theme of SONiC, right? So that's not what we're doing. With the enterprise SONiC, why people get this from Broadcom is, as I said, enterprise class support. B, it is a hardened version. Before this distribution we release, any version that we release, there are literally thousands and thousands of tests that we do. We do the quality assurance to make sure that it is a hardened version, there are no bugs in it, and customer can deploy it in production. So it is, it is a supported production ready release, which is called Enterprise SONiC. But then community release is also available. It has similar features and you can use that. In that case, then you will be responsible for carrying out the testing, making sure that it is qualified for the hardware that you are running with it. I hope I answered your first question. The second question you asked was about stacking. So stacking, okay, go on, Ramzi. I think you wanted to say something.
Yeah, allow me. It's me, Alayan. So with the enterprise SONiC, the application and the software itself, can people download it even if they do not purchase the support from Broadcom?
Could you repeat that? I don't know. There's a little bit of
Echo.
Echo in your noise today.
Yeah, apologies. I'll try to fix it. But in simple words, can people download the Broadcom Enterprise SONiC even if they do not purchase the support licenses from Broadcom?
In a few weeks' time, yes. So we are working on something like that. It will be available in a few weeks from our website, and we will advertise it. And people can download and use it. Correct. That will be available.
Okay, please.
Yeah. But then that will be, some specific releases that we will put publicly. Obviously, at the commercial level, there will be a little bit more option in terms of, they get updated very. Sometimes you get a release twice in a quarter, so that comes with some new features or bug fixes or whatever. So there will be some advantages, but still, people should be able to download it from Broadcom website, run it in their own network without paying any fee at all. Second question Ramzi asked is, we do not support, in SONiC, we do not support stacking. What is the alternative? So Ramzi, stacking typically has been used in campus environment. In the data center environments, for a long time now, people do not use stacking. So the alternative to stacking, previously, when they were more layer 2 type deployments, it was simply MC-lag, right? You create an MC-lag and you connect your devices to multiple devices. In a layer 3 environment, you can have ECMP. So if you are running, for example, a layer 3 host, then you can have 32 different connections going to 32 different switches, and you will get load balancing through ECMP. I will be, in fact, I'm going to start my discussion with some background on network virtualization and why we are doing these technologies in data centers and in campus, and hopefully it will answer your question there as well. So short answer, MC lag, and there is something called ECMP, ECMP load sharing. I will touch upon that when I go in details. So you will see there is a EVPN way of providing an alternative to MC lag, which is also an option. Hope I answered your question. Okay, you can mention in the chat window if you have a further question, and I will try to answer. Okay, so let's start today's session. It's going to be a busy session today. We'll start with talking about why do we use network virtualization. So remember, VXLAN, EVPN, etc. They are all a type of virtualization. But I want to start from the beginning. Why do we even need virtualization in networking world? And then I will talk about VXLAN, EVPN. Then we'll talk about how we configure VXLAN EVPN on a SONiC switch, and then we will do a lab. Okay. There was another question from Toti. What is Dell Enterprise SONiC versus Broadcom Enterprise SONiC? It's a one and the same thing. So Toti, the Dell SONiC, Broadcom SONiC, it's one and the same thing. It's exactly the same software. Actually, we brand it as Dell Enterprise SONiC, give it to Dell and they sell it. Broadcom, we do not sell directly to end customers. Broadcom work through partners, right? So we do not go and sell it directly to Deutsche Telekom or British Telecom or Etisalat or anyone. They will have to buy it through our partner like Dell. Okay. Or Edgecore and Stordis, and Distilogix may eventually become one of the partners who is directly selling this. So we will do a lab. Then in the next part, we will talk about monitoring. So we'll talk about what are different type of monitoring options you have, and we will finish off by with a demo of automation. So we'll show you some Ansible playbooks, and we'll show how you can configure some VLANs or interface, something simple, but how you can push your configuration through an Ansible script. So that will be our today's session. Let's start with network virtualization. I was expecting a colleague to join. Let me just quickly check if he is okay to join. Sorry. All right. What is network virtualization? So network virtualization is a way of carving out your single physical network into multiple logical virtual networks. It is similar to what you see on the server side. It's similar to a server virtualization. In server virtualization, you carve out your network, your CPU, your memory resources to different virtual machine. And each virtual machine believes that it is the only virtual machine running on the server. Similarly, you can carve out your physical resources in a network and create multiple virtual network. And each virtual network believes it is the entire network. Why do we do it? We do it because it provides us a secure and flexible means to share our physical resources. And when I talk about physical resources in networking world, I'm talking about your routers, your switches, your firewalls, your load balancers, and you can share these resources between different applications, different departments, or even between different companies. So why we do network virtualization? To share, it provides us a flexible and secure way. Both words are very important. Flexible and secure means to share our physical resources between different entities, different departments or companies. We will share the commands, Nasif, not a problem, okay? Maybe sign up, you can keep an eye on the chat and answer, yeah? Or Raj.
Sure, I'll do that.
Okay, so network virtualization can be classified in many different ways. One way of classifying it could be that you can have inline network virtualization, where every hop between source and destination is aware of virtual network, right? Examples of inline virtualization are VLANs or VRFs. I'm sure all of us have configured them at some point. So if I was to do network virtualization on this throughout this WAN link, I will have to create my VLAN or my VRF on each and every hop. Okay approach for a small network, but not a very scalable approach. Then how do you do network virtualization in a large environment? Answer is overlay network. So in case of overlay networks, we create a tunnel between the source and destination. So in this case, for example, this is a, if this is my network between England and Dubai, all the routers between England and Dubai, I do not have to create my VRFs and VLANs, etc. on every router. I don't. I'll just create this tunnel and I will get my kind of a pseudo private network. I will create an overlay network over this public network. Typical examples of overlay networks are GRE tunnels. In the past, we used to create lots and lots of GRE tunnels, and MPLS, which I'm sure all of you are aware of. So overlay networks are very popular, but does it mean that the inline networks are not useful? No, of course they are used as well. Yeah, this is a quotation I mentioned here. I like this one. When the going gets tough, network engineer gets another tunnel going, right? With GRE tunnels, that was the problem. If there are some people on this call who have as many gray hair as I, we used to create lots and lots of GRE tunnels and used to overcomplicate the network, but it was a good solution for a point problem at one time. If you look at the functional architecture, you do virtualization in campus, in WAN, in data center, etc. And you use slightly different technologies. I just want to give an example of campus network, and I want to give an example of inline network virtualization. So if you go to any customer or any partner network, partner building, their office, you will see that they can give you access to their guest Wi-Fi. I'm sure guest Wi-Fi, guest WLAN is a term which all of us have heard, right? But the funny thing is, if you look at the guest Wi-Fi, you are probably connected to the same access point, wireless access point, as the enterprise employee. But do you have the same level of access in their network as the employees? Answer is no. The question is, then how do they do that? Physically, you are connected to the same infrastructure. Answer is network virtualization. And in that case, they use inline network virtualization, right? There's a guest VLAN which is created, which can isolate the traffic from the external people, external users, and the internal employees. So it can provide you access control. In WAN and MAN, as I mentioned, GRE, MPLS, VPLS has been popular option for overlay virtualization. SD-WAN is now the key umbrella term that we use, and this is the technology that we are using on the wide area network side. Very popular, not a topic for today. And before you ask, we do not support SD-WAN on SONiC.
So
on the data, yes.
So Kamran, there is a question like, will Geneva overlay be added to SONiC?
At this point, it's a difficult question to answer for me because of what is happening with the accusation, right, with VMware. We do not have any immediate plans to support Geneva. In future, let's see.
Okay. Yeah.
Okay. Good question, Tony. So what do we do for network virtualization in a data center? Before I talk about technologies, and I know you already know the technology I'm going to talk about is VXLAN EVPN, but let's understand what is the use cases for network virtualization in a data center, right? Why do we do network virtualization in data center? The most popular use case is multi-tenancy. And what is multi-tenancy? Multi-tenancy is exactly what I defined when I mentioned network virtualization. It's a flexible and secure means to share same physical infrastructure between multiple entities. So you will have your same physical infrastructure, but you are creating a tenant for your HR department that is totally different from, say, another tenant for your engineering department. right? It becomes very important, for example, when you acquire different companies. Broadcom has a history of acquiring companies, right? Where Broadcom acquired Computer Associate a few years back, then acquired Symantec a couple of years back. This year we acquired AppNet, another company, and hopefully we will be acquiring VMware at some point. So when you acquire different companies, initially they have their different type of setup. They may have overlapping IP addresses, etc. So you want some isolation. Multi-tenancy can give you that. Another use case for network virtualization is you're forcing traffic through certain services. If you want to make sure that, for example, any traffic coming from Computer Associate and going to Computer Associate is a company that Broadcom acquired a few years back, right? So if we want to make sure that the traffic coming from this new company that we acquired to our traditional company, we want to make sure it is going through some firewalls. We can do that by creating different tenants. So that's another way, another use case for creating or having network virtualization in a data center. Third one is obvious. You want to have a different, you want to keep your management traffic away from your data traffic. They should be separated. And the final use case is interesting. It's also very popular. That is providing layer 2 connectivity over a layer 3 network. Now, layer 2 networks used to be very popular in data centers, right? We built large networks in past. I think I spent most of my time building these type of data centers for different banks and service providers and so on. We built them because they were very flexible, they were simple, easy to manage, cheap, and high performing. But there was one fundamental problem with the layer 2 networks in a data center. And that was they were prone to something called bridging loops. And I alluded to it yesterday as well, right? Bridging loops, they were, they are, I would say, very, very scary thing in a data center, in any network, but especially in a data center network, where it can literally melt down your whole data center network once there is a loop. So we created spanning tree protocol and, then rapid spanning tree protocol and multi-spanning tree protocol, and there were band-aids around it, bridge assurance, et cetera, et cetera. I think we created 20, 30 different technologies to avoid these loops in layer 2 networks. But eventually, everybody in industry agreed that that is not the right way to do it. The right way to go about networks is create layer 3 networks. So all the data center, modern data center networks, the main fabric, it is all layer 3. But the question is, there is still a requirement for layer 2 connectivity, right? Why there is this requirement? Because there are certain applications, specifically there are clustering applications which require layer 2 adjacency. And we cannot go about without it, right? We cannot avoid it. So to provide this, so that is one example. Another example, for example, and I have this little graphic for it here, animation here for this as well, vMotion, right? So whether it is vMotion from VMware or you're using someone else, when you want to move your virtual machine from one host to another host, you need to have same VLAN, right? And to extend that VLAN, now this is all layer 3 network, as you can see. Site 1, this is site 2. They are totally different sites. One is, let me say, in Dubai. The other one is, I don't know, in Abu Dhabi. And this is our layer 3 network. If you want this virtual machine, if you want the capability to move this virtual machine from host 1 in Dubai to host 2 in Abu Dhabi, you can do it by extending a VLAN. And you can do that with network virtualization. And once you have this, you have done that, you can do this vMotion, and without losing a single packet, this motion, this transfer will happen. So these are some of the popular use cases why we require network virtualization in a data center. So there are functional requirements, as I mentioned, and there are security requirements, as well as there are compliance requirement, right? So every industry have some sort of bodies which will dictate these are the compliance that you have to do, right? There is payment card industries, PCI compliance, and there are other industries. All the industries will have some kind of rules and regulations. Many of those dictate that in your data centers, you have network virtualization. So how do we do network virtualization in a data center? Very high level. We create overlays, right? So we have this layer 3 fabric, which is underlay. And then we create overlays. We create these tunnels on it. There are different types of overlays that we can create. These overlays could be host-based, where you create these tunnels, whether they are Geneve or VXLAN, whatever technology you are using, between one server to another server. So this is the approach which, for example, VMware takes, right? You have NSX in VMware, and you can use this. There are other options available, open source options available as well, that you can use for this type of host-based overlays. There are switch-based overlays. This is the approach which I believe it is still the most prevalent one at this time. Although the host-based overlays are becoming more and more popular, but as we are talking now in 2022, I believe there are still more switch-based overlays I see deployed compared to host-based. And this is the approach. Host-based overlays is the approach there. You have you see from Cisco, Juniper, Arista, all the mainstream traditional data center OEMs. The one difference between the two approaches is that with the switch-based overlays, obviously you need more intelligent switches, but your servers do not have to do a lot of things from networking point of view, right? They can just do what servers are doing, traditionally what they're doing. With host-based overlays, you can have a simpler and hence cheaper network. And the more intelligence is on your servers, on the NICs, they use smart NICs, they use DPUs on the NICs. You can do a lot of hardware offloading to your NICs, and you can run host-based overlays. So your network is cheaper, less intelligent, your servers are more intelligent. Another benefit of this approach, host-based overlay approach, is that the blast radius is small. If there is a problem, you will only be impacting VMs running on or containers running on one server. Whereas if the blast radius of a switch will be bigger, if there is a problem on a switch, then it will be impacting, I don't know, 30 servers connected to it. And then obviously 30 servers will be running hundreds and hundreds of virtual machines. And then there are, control. There is sometimes there is internal politics involved within the company, depending upon, if you're, so traditionally, if you look at, it's still the case if you look in the companies, there are different teams who manage servers and there are different teams who manage the network. So server teams sometimes want to keep control to them, and they say, and they are already using, for example, VMware. They say we want to use the VMware overlays, whereas a networking team thinks, oh, then we will give the control of the network to the server team, what we are doing. And they say, no, we still want to go with the network-based overlays. So sometimes there is this political dynamic involved as well. And depending upon who has more clout, they will win the case. But the third type of overlays, which I believe will continue to be very useful, whoever wins this war between host and server switch, will be the hybrid overlays, where you initiate a tunnel from a server and it is terminated on switch or vice versa. And I increasingly see that this approach is being adopted by customers. One of the presentations I'm going to do at OCP next month will be with a customer who has deployed this type of environment, where they initiate tunnels, initiate and terminate tunnels on the host space, on servers, but at the same time, they do it on the switches as well. So a hybrid approach. Hope it makes sense. Any questions so far on this topic? No? Okay, let's continue.
I see a couple of questions, if you don't mind, in the
Sure.
chat. So I'm not sure if you addressed them. Like, there is a question about, will Geneve You have answered it. Apologies then. Okay, thank you.
Yeah, no problem. Okay. Another thing that I want to talk about before I go into lab is now, traditionally we have used three-tier environment, three-tier architecture in our campus: access, distribution, core. Now we see that the trend is changing and customer want to use, the whole industry, I believe, is moving towards a VXLAN EVPN type environment in the campus. So it is not just, for example, we at Broadcom are pushing this type of architecture. You will see Cisco is also doing that. Juniper is also doing that. Arista is also doing that. Extreme is also doing that. All the main players in the market are moving towards this direction. So the question that we as technical people ask, why we want to do that, why customers should use these type of why they should move to this architecture in campus. Okay, most of the, I can share some link, but if you just Google, for example, the host-based overlays are what NSX does. And the hybrid overlays are available once again through all these vendors. So you can do it with SONiC, you can do it with Cisco ACI. So if you look at Cisco ACI, they have these virtual switches option, yeah, which run on the server, and the tunnel can be terminated on the leaves as well. You can same thing can be done with SONiC with the Open vSwitch type environment. So it is yeah, it's already out there. Okay, thanks for the question. VXLAN EVPN in campus. So why should you use this architecture in campus? Because you can use a layer 3 environment on your campus, which means that you can eliminate spanning tree protocol, which means that there is not only that there is no fear of any loop, but also you should be able to use all your links. So remember, with spanning tree protocol, when there is a redundant link, what do? We block it. So in this case, there won't be any blocking, and you will be able to utilize all the links in your network. The second thing is the VXLAN EVPN type solution is more intelligent, right? What is a traditional way of learning in a campus environment? It's flood and learn, right? You connect your devices to the switches. Eventually, devices will talk. Initially, everything will be unknown unicast. It will be flooded, and eventually, everybody will learn everybody. So that's flood and learn. There is no control plane to exchange the endpoint information. In case of VXLAN EVPN, your EVPN, which is a BGP address family, you will be able to, you see that if a host is learned on leaf 1, its information will be shared through BGP to other leaves. So there won't be any flooding in the network. So that is a more optimal way of communication. Another reason is it is standard-based deployment. So you can still connect your legacy environment with your new this VXLAN EVPN based campus environment, because these switches can still run your connectivity, traditional connectivity like port channels, like spanning tree protocol, etc. Your leaf are capable of doing it. So if you connect them to a external legacy environment, there will be interoperability. Another good thing about it, and I would like you to pay attention to this point because it is important to understand, is you can build your VXLAN EVPN environment on top of your existing access switches. So your access switches do not need to support VXLAN EVPN. They can continue to use the traditional connectivity that they had, and they can just have a MC lag connected to the leaf switches. So with this approach, you can continue to use your brownfield environment And still you have the capability now to extend your layer 2 over layer 3. So now you will be able to move, for example, any host from this access switch and to another switch block, which is maybe a different building, and you can still be able to extend your VLAN between these two buildings, thanks to VXLAN EVPN. So it is all here, as you can see this cursor. This is all layer 3 environment, but you will be able to extend your layer 2 over it, your VLANs over it. So layer 2 extension is allowed for mobility, and it is simple environment. It is very resilient. As you can see, all the access switches are connected to at least 2 leaf switches with EVPN multi-homing, which will be supported in SONiC in the next version. You can connect them to multiple, not just 2, you can connect it to 30 or 16 different switches. So there is a lot of resiliency available. And also these leaf switches are also connected to multiple spine switches. So it's very resilient design, and it is very scalable. You want more ports, you want to connect more hosts, you add more leaf switches. You want more bandwidth, you want better performance, you add more spine switches. As simple as that. So you can scale horizontally. You will hear this term, horizontal scaling. What does it mean? It means that, as I said, if you want to connect more access switches, you want to add more hosts to it, you will add more leaf. You can connect here, or if this is filling up, you add more leaf switches and it will give you more ports. You can increase the density. But if you want more bandwidth between the leaf and eventually between the host, you add more spine switches, right? And you connect them. So this is why we say, you can scale horizontally rather than vertically. And this horizontal scale, it's a very scalable architecture, and that is why it is used in all the mega scalers, all the big environments. Hope it's making sense. Okay, so that's what I wanted to cover in the VXLAN EVPN or in the virtualization section. If anybody has a question, this is the time to ask. Otherwise, we'll move on to our first lab. Is there any question? Will multicast still work through across VXLAN EVPN? So this is a good question. Multicast, as of today in SONiC, it works in the default VRF and it works, everywhere. But if you want to run multicast within VXLAN EVPN, that is a feature which is currently not supported. It is called tenant routed multicast, and it is a feature on the roadmap. Typically, it is a requirement. What I have seen, it is only a requirement for banks, because they use a lot of applications which need this multicast. For service providers, for other enterprise customers, it is not a major requirement. I hope I answered the question. Okay, BGP underlay. So this is the lab that we want to do now. And then we will move to VXLAN EVPN. So what we are going to, discard. Okay, so what we want to do in this lab is very similar to what we did yesterday. Very simple. We have this 3 router topology, and rather than running OSPF, we will run BGP here. Yeah, so very simple. I have the commands here. I'll put this down. And so let me first walk you through the configuration that we are going to do. So interface IP addresses we talked about, I believe they are already configured. Loopback, I will check. If it's not configured, we will configure it. How do we configure BGP? Very simple. Router, BGP, and the AS number. You should assign a router ID. Otherwise, it will automatically be picked up, but randomly. You go to address family IPv4, in our case, I prefer using redistribute connected rather than network and every network. So I think it makes sense in a clause topology to do redistribute connected. And then you will create your neighbors. In our lab setup, as you can see, we have leaf one is only connected to, I hope it is big enough for you guys to see. Leaf one is only connected to spine. Leaf two is only connected to spine, and spine will have two neighbors. So just one neighbor statement for leaf one, and we will activate it in IPv4 address family. As a best practice, I recommend that you add these commands. Always compare MED. So MED is one of the BGP metrics, and by default, it is only compared, only used for best path selection if the routes are received from the same remote autonomous system. With always compare MED, you will compare it even if it is from different AS. By default, BGP does not support multi EV, what's the word for it? Equal cost multi-path, ECMP. We want it to definitely support it. You don't need it in this topology because there is only one link, right? But obviously in a production environment, you will have at least 2 spines or 4 spines. So you should do this command, maximum path. And I recommend just do 32. So you can forget about it for both for eBGP and IPGP. So this is the configuration that we are doing, and we have configuration samples available for each leaf. So we can very quickly go through this lab together. Okay, I'm going to connect to my switches, telnet, and I will zoom in. I think it's not big enough. Okay, admin and Broadcom. Okay, let's have a look what we have on leaf on show IP interfaces. Yes, so the IP is already configured. Loopback is also there. VLAN is there. Ping 1.1.1.2. So if you remember, .2 was our spine, the other side, right? So we're pinging from leaf 1, and we can ping it. So that is good. Spine. Telnet. Zoom in. SONiC CLI will take me to the industry standard CLI mode. And let me check, show IP interfaces. Interfaces are up and configured. So ping 1.1.1.1, leaf 1. I can ping leaf 1. And let me ping leaf 2, 2.1.1.2. So I can ping leaf. I can't ping leaf 2 actually. Okay, so something is wrong. We'll check that. Link is up. And unable to connect. There's something wrong with it. I'll stop it. And let's see, start. Yeah, it's not a happy fellow. Connection refused, unable to connect. Stop. Okay, looks like I'll have to stop the whole topology. This will take a little time. I'll stop and restart it. Let me show you where I'm running these. This GNS3, I am running it in Azure. By the way, for if anybody at the moment you do not have a big enough server or access to a big enough laptop server where you can run GNS3, one interesting thing that you can do is you can actually get a evaluation from Google Cloud, and that is free for 1 year. So that's what I've done, right? So it was free for 1 year. You get some credit that you can use, and you can get a server there, a good size server, right? And because you have this free $500 or something like that, $300, and you can run your GNS3 there. So it will give you two benefits. One, you will learn Google Cloud, right? And number two, you will have this free server to play with, and you can do GNS3, and you can learn SONiC, you can run other operating systems as well. That's another good thing about GNS3, right? You can run SONiC here, you can also run Cisco, you can do interoperability testing. I know some people who have done it. I've also done it with Cisco Nexus switches, firewall, etc. So you can, if this is something that you enjoy, I would recommend that you try that. It's interesting. Okay, it is giving me grief at the moment. I might need to look at my server in Azure. So go to portal.azure. Sometimes these troubleshooting sessions are actually more beneficial for the attendees, because you learn a lot more than what you have learned if there weren't any issues. So yeah, it is running already. If you can see what I am running, this what Azure called a D8S v3. It's got 8 virtual CPUs and 32 GB memory. Okay, stop the machine. Obviously, this will lose. Yep, so I've lost the connection. You can see. And refresh it. And start it again. Do you want to start all the selected virtual machine? Yes. I should probably move it to EMEA. This is in US. Okay, should be up by now. It says run. No, it's still running this. Okay, so as soon as this comes up, I hope the IP, IP wouldn't change. I have a static IP here. And in GNS3, 20, 80, 73, 52. Yeah, so the IP is same. We will see this connection will come up. I should have the server summary here. So we should see this GNS3 server coming up here. So in case you don't know, you go to preferences in GNS3 and in server, and here you mention remote main server, and that is where you put your IP address of the remote server. So in this case, this is a public IP of my virtual machine that I'm trying to connect to. Why it says deallocating? I hope Azure is not having issues. Okay, succeeded. Okay, so this is succeeded. Okay, so this should be connecting soon. Connection refused. Ah, there you go, finally. Can you see this now? It says GNS3 server, blah, blah, blah. It is. Keep an eye on the CPU. So I'm going to start the topology again. I hope it is big enough for you to see. I'm going to start it again. You keep an eye on the CPU. This will start going up. So I think even when I'm running, when we'll run VXLAN EVPN, I think it will be a good time. Remind me if I forget. We'll check the RAM usage. So I've got 32 GB RAM here, but I think you can get away with a smaller RAM as well. So we'll have a look at how is the RAM doing when we run VXLAN EVPN, because then it's like heavy usage. Okay, so now the leaves should be coming up again. So let's connect to leaf 1. Connected. Admin Broadcom is my password. Okay, SONiC CLI. SONiC CLI didn't work. You know why? Another interesting thing. Maybe I think sign up covered this earlier. Show system status. When you log on to a SONiC switch, you will see that services come up one by one, right? Like any other switch. But here you can see, okay, so BGP, this is a separate container. It is still down. TeamD is another container. It is down. And this management framework, that is where you have your Clash running, where you have the SONiC CLI running. So it is down. That is why I could not connect to SONiC CLI. It will be coming up in a sec. You will see that there will be a message here saying system is ready. Okay, and how soon it can happen depend on the CPU, the power of the platform. Okay, telnet. Okay, admin. Can you see the CPU? 76%. So CPU really shoots up when you start up all the machines. All the switches. It will go down once they are up. Show system status, and it should have a very similar status. Everything is up other than the management. Oh, there you go. Can you see this? System is ready. System is ready. So if you do show system status now, this is what you will get. System is ready. If I go to SONiC CLI, I am in SONiC CLI, right? Now let's look at leaf 2. Hopefully this should work now. This was the one giving us grief. And it is available. Somebody trying to speak? Feel free to ask a question if you want to. Okay, so we are connected to all the switches. Let's start with leaf 1, if that's okay. Yeah. So what are we doing? We are going to run BGP here. So this 3 router topology, we will be running BGP. So we can exchange routes from here to here. There is network 10 on this side. There is network 11 on this side. Okay, so show IP interfaces. You can see there are 3 interfaces, ping 1.1.1.2, the other side, I can ping. From here, I can ping leaf 1, that is good, and ping 2.1.1.2. I can ping leaf 2 as well, so that's good. Okay, so this looks much better now. Let's start with configuring leaf. So there is no OSPF configured here now. So if I do show run OSPF, there is nothing. And also you don't have any BGP configured at either end. Oh, BGP is already configured here. Which one I am running? Okay. Okay, not a problem. I will remove it and then run it again. No router BGP because I want to show you how it is running without AS number. Good. And now to show run BGP. BGP is gone. Here as well, show run BGP. Yes, okay. No router BGP gone. No router BGP gone. Show run BGP. Okay, it's gone now. So at this point, if I do show IP route, I only know the directly connected one. Can you see that? Only the directly connect, CCC, only connected one. Do I know network 11? No. Do I know about the loopback of other switches? No. We will once we start the BGP. And this is our configuration that we want to use. So we will run BGP on leaf 1, we want to use this AS number. So mind you, here we are using BGP in the data center. And the recommendation is that you use eBGP in data center, external BGP in data center. And you use it in this way that every leaf should have its own AS number. All the spines should have the same AS number. And then all the super spine should also have the same AS number, right? So if there were even 2 spines there, I will use same AS number on those spines. But what about leaf? Each leaf will have its own AS number. This is RFC, if I remember correctly, 73 something, 7329, etc. But you can just Google and you'll find it. This is the standard for running BGP in a data center. Okay. So let's configure BGP. What we are doing here is our router ID is the loopback. The best practice for always compare MED. Maximum path as a best practice. Redistribute connected. So once we do redistribute connected, what will happen? These connected routes will be advertised. No problem, Bashar. Welcome to the training. And then you do neighbor. Now, what is 1.1.1.2? That is spine. So leaf 1 only has 1 neighbor. And what is the AS number at spine? So remember I said it should be different, 65,000. So you can tell that this will be an eBGP connection, different AS number. And we are only activating address family IPv4 at this point. So fairly straightforward configuration. Go to leaf 1 and configure it. And that's it. At this point, if I do show BGP IPv4 unicast summary, it says that, it's never came up or down. Active doesn't mean it's working. It should be established once it is up. So at the moment, it knows I want to create this neighbor, but it is at the moment it's down. Let's go to spine now, shall we? Now, Spine is running in AS 65000. This is its loopback IP, and it will have two neighbors, leaf1 and leaf2. And these are the AS numbers we are using. For leaf1 is 65101, leaf2 is 65102. That's how I generally do. So, 65101, 102, and so on. It gives me kind of up to 100, up to 99 leaf in a pod with this scheme, right? 65, 101, 102, 103 to 199. You can use any AS number. I mean, it doesn't matter as long as RFC says you use different AS number on each leaf, then same AS number on all the spines. Right, let's deploy this configuration. Let's go to our spine. And now to show BGP IPv4 unicast summary. And you can see that we have an established connection now with 1.1.1, which is leaf1. Why it's calling this neighbor 111? Do I have the router ID in the command? I do. Anyways, 192.160.1 show. Okay. Okay, show BGP IPv4 unicast neighbors. Okay, so yeah, here it says. Right, of course, because I'm using neighbor and the IP. That's why it's saying that. You can see the router ID here is the loopback ID. Good. So this looks good. The BGP up between spine 1 and leaf 1. Now let's bring leaf 2 up as well, and then we should be seeing some routes. What do you think? That should leaf 1 already be advertising its loopback and network 10 to spine 1 already? I believe it should. So come on. Let's do show IP route. And it is. So we can see there are two BGP routes here. And network 10 and 192.168. So spine, the leaf 1 is advertising its loopback and the network 2 spine. So this is working fine. And we go to our final leaf 2, which again is not responding. I don't use GNS3 very often, so there's some intricacies here that I can improve on. I think this idle timeout, I think I should improve. Okay, configuration mode, leaf 2. So I have the configuration here. So this is the leaf 2's AS number, router ID, and only one neighbor, which is spine. There you go. Show BGP IPv4 unicast summary. One neighbor, and it is up, and it is receiving 5 prefixes from it already. Show IP route. There you go. So you can see we are learning BGP routes here. Network 1 is coming from the leaf 1 side. This is the loopback of leaf 1. This is the network 10.1.1 on running on leaf side, and this is the loopback of spine. Can leaf 1 now learn networks on the leaf 2 side? And yes, it can. Network 11 is now learned. Okay, so I can quickly ping from here. Ping 11.1.1.1 is the IP on the other side, and I can ping it. Okay. Right, any questions so far? Go to Zoom and see if there is any chat. looks like no question. So hopefully everybody is happy with it. So that was our lab 2, where we were able to configure BGP underlay. We were able to configure BGP in default VRF in our small little topology. Now let's move on to our next step, which is to configure the VXLAN EVPN. So that's the interesting one. Okay. So how do you configure VXLAN EVPN now? So remember I mentioned that EVPN is nothing but a BGP address family to allow to advertise not only IP address, but also MAC address, because we want to advertise our host information in BGP. So remember I talked about, I said that you don't do flood and learn with VXLAN EVPN. You will use your control plane to advertise information of host between the different switches. How do we do it? Thanks to EVPN. That's how we do it. So EVPN, that's an extension to BGP address family, and the address family is called L2VPN. So this is what we are going to enable. So how many configurations you need to enable BGP EVPN on Spine? Answer is 1, and that's it. It could not be more simpler, right? Address family L2VPN EVPN, and you enable it on you activate it for each neighbor, and that's it. That's all you need for Spine. But configuration on the leaf side is a little bit more involved. So this is the time for everyone to be active. If anybody was doing anything in the background, please stop doing that. This is the time you need to pay attention to what I'm going to talk about, right? Because this will actually help you understand how you do all this configuration, which is very important. Okay, so first thing, you enable your VXLAN interface, VXLAN VTEP. So remember I said, you'll create these tunnels to carry your information, to carry your traffic. VTEP is the virtual tunnel endpoint. VTEP stands for virtual tunnel endpoint. This is the endpoint of the tunnel, source and destination. So you define your IP address for the tunnel. This will be an additional loopback. So you will see that on each of leaf 1 and leaf 2, I will create another loopback, which will act as the source of the tunnel from that leaf. Then you enable your VXLAN EVPN, BGP EVPN family on the on your switch. So BGP is already running in IPv4 family. We will enable it in the L2VPN family as well. This is the command that tells the switch that you will be advertising all the VNIs that you're going to configure. So remember, VNI is the identity of a segment in the VXLAN environment. You can say it is analogous to, similar to VLANs. But there are differences. VLAN are limited. There are, how many VLANs you have? You can only have 4,096 VLANs, that's it. Whereas in case of VNI, when you go to VXLAN environment, there are 16 million VNIs available in the VXLAN. So from a scalability point of view, it's large, right? Because there are more bits available for VNIs in the VXLAN header. And you will see that we will do one-to-one mapping between a VLAN and the VNI, because on the server side, on the host side, and a segment is identified as VLAN. Server in this case would not know about what is VXLAN. They don't care. But as soon as that packet enters your fabric, your leaf switches, leaf spine switches, at that point, we will do this translation. We will add this additional VXLAN header on top of your the packet which came from your host. And that additional header, that VXLAN header, will contain the VNI information. So we will do this mapping that, for example, VLAN 10 corresponds to this particular VNI, say 1010. And you will, and VNI will be mentioned in the header that we will attach to any packet of VLAN 10. Okay. Now the next step is to create a tenant. So remember, tenant is a logical construct in the VXLAN EVPN environment, right? We use tenants, as I mentioned. We create these multi-tenancy for security purposes, for compliance purposes, and these tenants are basically created by configuring VRFs. So each tenant corresponds to a specific VRF. In our lab today, we will be creating one VRF. I'll call it VRF1. We will configure BGP in that VRF. So BGP is already running in default VRF. We will run it on the new VRF that we'll create. Advertise address family. We'll go to address family. Advertise IPv4 unicast. So that is also a very important concept. Pay attention here. With this command, we enable the advertisement of type 5 of EVPN environments. So remember, there are 5 types of advertisements in EVPN, in BGP EVPN family. We will typically use with 2, 3, and 5. The type 5 is the route, which is basically your prefix route, which is your subnet route, /24, /16, and so on. Type 2 route is basically your host route, that's /32 IP. And that type 2 route will also contain the MAC address of the host. So that is the host advertisement. With advertise IPv4 unicast, we are saying we also want to advertise type 5. If you don't configure this command, you will not see any type 5 advertisements. And I'll show you in the lab. The next step is that you will create what is called an IRB VLAN. So IRB VLAN is the integrated routing and bridging VLAN. In VXLAN environment, in VXLAN routing, there are 2 modes of routing. One is called asymmetric mode, and the other one is called symmetric mode. SONiC uses both the modes. But in many of the use cases, it's symmetric mode which is more important for you. By the way, in Cisco environment, and I have a Cisco background, they only support symmetric. They don't even support asymmetric. In case of SONiC, we provide both options. But here we are focusing more on symmetric in this lab. In symmetric mode, whenever all your communication between your different segments, your layer 3 communication, say communication between VLAN 10, VLAN 11, and so on, all that communication will carry the IRB VLAN VNI. And I will show you that. So this is a very important VLAN, IRB VLAN, and you will configure one IRB VLAN per VRF. I know at this point, if VXLAN EVPN is new to you, you won't be understanding it 100%, but bear with me. Once we have done the lab, it will become more clear. So one IRB VLAN needs to be created for every VRF, but once only. Then server VLAN. So these are the VLANs which are connected, which are configured on your servers, which are connected to your host. So how many of server VLAN you will have depend on how many VLANs you require in your environment, right? In your data center. So you may have 1,000, 2,000, 20, whatever, right? For every VLAN, you'll configure, you'll go, you create that VLAN, and then you will go to your VTAP configuration, interface, VXLAN, whatever, and you will map your VNI to VLAN. Remember I mentioned that if you look here, so you have VLAN 10, the identity of this segment outside of this fabric is VLAN 10. Once the packet enters this fabric, nobody can see VLAN information. There is no VLAN information actually that we are carrying. It will be the VNI information which will be carried throughout this fabric. Once it comes out, we will once again do the reverse mapping. We will map from VNI to VLAN and send the traffic. And the final step in our configuration, the 5th step, is to configure Anycast IP address. So this is the IP address that you will configure on the SVI, on the interface VLAN on your leaf switches. Why we call it Anycast address? Because we use the same IP address for, say, VLAN 10 on all the leaf switches. So if there are 10 leaf switches and you need to configure VLAN 10 on all 10 leaf switches, you will use the same IP address for VLAN 10 on all of them. That is why it is called Anycast. Why you configure same IP? Because imagine if you have a virtual machine on leaf 1, which moves to leaf 10, you want this virtual machine to continue to operate as if it is still running connected to the same switch. You do not need to be able, you do not want to have this need to change the any configuration on your VM when it moves. You want it to be very transparent. And that can only happen if the default IP remains same. And to keep the default IP same, you want the same IP available on all the leaf switches, hence the Anycast address. So we will configure the Anycast address as well. So that's the 5-step, and that is the configuration that you need to enable VXLAN EVPN. Let's jump right into the lab and let's do this configuration. But before I do that, if there are any questions, please ask so I can take a quick break, water break. Okay. No questions so far. Hopefully everything is making sense. Let's go back to the lab, guys. Okay, and then we will go to monitoring. All right, time is a bit short. I have this, these are the configuration. There you go. So I have my configurations already built, so we can very quickly cover that. Where is my GNS3? Okay. Okay, I need to reconnect. Okay, that's my leaf 1. Let's go to SONiC CLI mode. By the way, you could do this configuration from click and FRR as well. But as I said, my recommendation is stick to Clish. It is very simple. And we're doing a lot of testing on the Clish side. A lot of the new feature, these all APIs that we create, they all supported on the SONiC CLI side. So better to stick to SONiC CLI. But we have customers who are running this in production and they still use Click. They still use this default CLI, Click, and FRR. That also works. So from a support point of view, we still support it. No problem there. Okay. SONiC CLI. All right. Let's start with leaf 1. And here is my configuration. I will share these configuration files as well that I'm showing here. So you don't need to make any notes if you don't want to. Not this one. This one. Okay. Okay, so we are starting with spine because that is an easy one. So remember I said on spine, you only need this command, address family L2 VPN EVPN. You need it in the router mode and then for every neighbor. You activate at this address family. So there you go. Let's try and push all this config in one go. Configuration mode. And there you go. User accepted. Okay. Leaf 1. So I'll do it step by step so it makes sense to you guys well. Is this quite big enough, Mohit? If you look here, this text is easy to read, or should I zoom in more?
It is okay for me. If you guys have any issues in seeing it, let us know in the chat. But for me, it's okay.
Perfect. Thank you. So we will create a new loopback. Remember I said we need to create this loopback, which will be the source of our VXLAN tunnels. So we'll create it on leaf 1 as well as leaf 2. We are creating this new VRF. Anycast MAC address, why we are configuring it. So remember I said we want to use the same IP on each leaf. So if VM moves, it gets the same default gateway everywhere. Well, you want to use the same MAC as well, right? Because your VM is not gonna go an R for the default gateway. It's gonna assume that the same IP, same MAC is on every switch when it moves. So you want this. So we will configure this Anycast MAC on every switch. Same once again for a specific switch. This is the IRB VLAN that I'm talking about. So this VLAN, you won't be connecting any host in this VLAN, right? This VLAN is purely there for this layer 3 communication. For any other VLAN, VLAN 10, VLAN 11, when they're talking, they will be using the VNI that we will assign to this VLAN, IRB VLAN. So it's only there to allow layer 3 communication. I tend to use a VLAN number for it that I'm not using anywhere else, just to, for clarity. When I look at this VLAN number, I know this is my IRB VLAN. Why you need IPv6 here? You need some IP address configured on this VLAN for your DHCP relay configuration, right? We are not doing DHCP relay configuration here today, but I wanted to kind of highlight so it's, otherwise we have seen customers struggling with this for a few days and raising a case and then Sainath or Raj telling them to configure it. So I wanted to highlight it. So you should, I just find it easier to enable this IPv6 enable here. Okay. I'm configuring interface VLAN, and in fact, interface VLAN is already configured, VLAN 10. At the moment, there is an IP address configured here. Let me show you that. Interface VLAN 10, right? So it's already there. I want to remove IP address so I can configure the Anycast address. Hope it makes sense. And we are putting it in VRF1. You can put any description there which makes sense in your environment. Then we'll go to router mode, BGP mode, and then we will enable the L2 VPN, EVPN. Remember this command to advertise all VNI, and we enable address family L2 VPN for our neighbor as well. We'll go to the VRF mode, but before I go there, let me push this configuration first. Creating new loopback and creating a VRF. Let's do that configuration. Okay, it worked. No error. Let's create our IRB VLAN. Good. Let's create this interface VLAN 10. So VLAN 10 is there, but we want to change the config to Anycast now. And we are putting it in a VRF. It worked. Good. And let's update BGP and enable BGP on the L2 VPN family as well. So if I do now show BGP L2 VPN EVPN, no BGP neighbor in L2 VPN family, right? Which makes sense. Once we have enabled this, we should see a neighbor. 1.1.2. There you go. Now we can see that 1.1.1.2, as you know, is the spine. So L2 VPN connectivity is also there. Good. Okay. Let's enable BGP on the VRF. Redistribute connected will help redistribute our VLAN information, right? The VLAN 10 is in VRF 1, and with redistribute connected, it will be advertised. And this is the type 5 advertisement, advertise IPv4 unicast. Something went wrong. What happened here? Oh no. Okay. Router BGP 65101 VRF1. Okay. Now sometimes copy paste doesn't work for this command. This one hopefully will work now. Okay. I will check. There is no extra configuration there in a minute. Okay, this is the final set now. This is, we are creating our VXLAN interface. This is the interface, which this is a logical interface, but this is where all the VXLAN tunnels will be created through this interface. So what we are seeing here is source IP.
Kamran, if you allow me, I'll have to go offline for a second, I mean, probably 10 minutes, but you guys can continue, no issues, if you don't mind, please. Thank you, guys. Thank you.
No problem. Yeah. Okay. So this is the source IP, and what we are doing here, look, we are mapping out VNI number that work for you. Okay, so create it again. And that's it. That's all the configuration I need on leaf 1. Spine is already done. Let's go to the last part of our configuration for leaf 2. Leaf 2. Oh no, leaf 2 is giving me some grief. What is wrong with you? 5010. Okay. Let me just save. Ah, this is working. Spine 1 is not working either. Saving the config on. Okay, at least this is working. Spine 1, right mem. Yeah, GNS3 is not perfect. $5,010. Okay, I'll give it a minute. If it doesn't come back, unfortunately, we will have to kind of reload this again. But the configuration is save on spine and leaf 1 and spine, so it will only be spine leaf 2 that we will need to reconfigure. Leaf 2. Why I can't stop it? No, it is stopped now. Good. So let's restart leaf 2. And we will need to configure it, I think, underlay here as well as overlay. So won't take much time anyways. It is still 5010 and it is loading. Good. So let's give it a couple of minutes and then we can configure leaf 2. Let's keep them warm. Yeah, 39-40% CPU and RAM is quite low, 28%. So it shows that probably less than 32 meg should also work for this type of topology for sure. I remember, I mean, I had 32 meg on Google Cloud, And I was able to run quite large topologies with 32 meg. Okay, so while this is loading up, any question, guys? This is a good time to ask a question. Show system. Status. Management framework is not up. Give it one more minute. No Q&A. Okay. You guys are very, very quiet today. Just give me something in the chat window. So can you maybe mention where is the location of enterprise SONiC image to load on actual physical switches? I have Celestica DX10. I don't know if we support Celestica DX10, Sai. Have a look at that if you don't mind. I don't think we do support it, but yeah, it will be available. We will advertise it. It is not there at the moment. When it will be there, I think we are planning end of next week, but you know, to be on safer side, give it a couple of weeks. If everybody, whoever can hear me, if you don't mind, please share your location where you are based. Let me just see who we are talking to. So we have around 20 plus participants here. Mamar is from Tunisia, okay. Toti is from San Diego. Ramzi from Lebanon, Nawab from Riyadh. Al-Mutaz from Sudan, Bashar from Abu Dhabi, Abdus Salam from Algeria. Nice, nice, nice. Glad to see people from so many different geographical regions are all here. Thanks for technology, right? We can share knowledge with each other so easily. Okay, good, good, good. Salma from Morocco, Ahlan wa Sahlan. Sudan, okay. Good, good, good. Toti, if you are in San Diego, I don't know if you're planning to attend OCP Summit, but if you are that is 17, no, that's 18, 19, 20th in San Jose, so not far from you, I believe. So I'll be there. You know, feel free to reach out if you're there. It'll be good to meet face to face. Okay, good, good, good. Very nice to meet all you guys. Let's see what Leaf 2 is feeling now. SONiC CLI, show run BGP, I think underlay is configured, show IP route. It is learning the route, so underlay seems okay. Network 10 is not here. Okay, I know, because that's in VRF now. Okay, so let's configure Leaf 2. This is my configuration for Leaf 2. Lab 3, yeah, this is the one we are looking for. Leaf 2, start from here. Configuration mode. So I'm not going to repeat. You know, you already know what we're doing here. IP creating VRF. Very same configuration. Did you notice the only difference here is the loopback one is different, right? For Leaf 2, but otherwise it's identical configuration I'm doing. It makes automation very easy when you have these type of scenario. Here we are configuring VLAN 11, so obviously IP will be different, and then VNI will be different. Oh no, didn't copy properly. Okay, and let's go to router. Yeah, this command was giving me grief, right? So just do router BGP manually 65.102 for leaf 2. And now I think copy paste should work. Neighbor is only one, which is spine. Okay, and let's configure it in VRF. And enable it for IPv4 and L2 VPN family. Good. Let's see if the neighborship is up. Show BGP L2 VPN EVPN summary. Yes, not only the relationship is up, we can also see some prefixes coming in. So that looks good. Show BGP L2 VPN EVPN routes. So remember I mentioned there are multiple type of routes. So if we do route, you will see there is a type 5 route, which is a subnet, as you can tell, right? It's /24 10.1.1.0 that we are receiving. And there's a type 3 route, which is about the VTAPs. Type 3 routes advertise the VTAPs. So we know there is 100.1.1.1 VTAP, which is leaf 1 out there. We don't see any type 2 advertisement, can we? Because no endpoint is talking. So once endpoints start talking, then they will be learned by the local leaf, and then they will advertise information to the remote leaf. So let's generate some traffic from our endpoints. Tell it 50, 13. It's my PC1. I'm going to ping my local gateway, which is 10.1.1.1. Let me make it bigger. So I can ping my local gateway. Now it will be advertised. It will be learned. Once it is learned, it will be advertised. So let's go to leaf 2. Do we know any type 2 now? And you can see that now we know there is a type 2 advertisement. Can you see that? Type 2. And it is /48 because this is the MAC. And then 32-bit /32 10.1.1.0 10. So why /32? Because it is host. So we have learned our endpoint PC1. We have learned it at leaf 2. How? It was learned when it spoke by leaf 1, and then it used EVPN type 2 advertisement to advertise it to leaf 2. So leaf 2 now know about it. So no flood and learn. We are using a more optimized way. Let's do the same for our PC2. Is Koti on the call? Koti, maybe you can type if you are.
Yes, Cameron. I was there.
Okay, perfect. I'll hand over to you in 5 minutes.
Oh, okay.
50, 16. We might have to make it a little shorter if you don't mind your session, because we had some issues in the lab. It's a bit slower.
Okay.
Okay, thank you. All right, so I'll ping my gateway from, so remember PC2 is connected here. Its default gateway is leaf 2 11.1.1.1. PC2 11.1.1.1. And the IP of PC2 is 11.1.1.10. So PC2 will be advertised, and we will start seeing that. Can I just look at one type of advertisement? Answer is red. Yes. So you say root, and then you say type, and then these are the options. Type 5 is called prefix. Type 2 is called MAC IP. So I want to look at type 2. I'll say MAC IP. So we can see this now. 11.1.1.10 is not here yet. It will be. It will become in a minute. Okay, try it again. Yeah, leaf 1 is not accessible, but hopefully it is still working. We'll see. Now, if I go to my PC2, oh, it's already there actually. Yes, if I go to my PC2 and now try to ping the other side, 10.1.1.10, it is saying not reachable, destination network unreachable. Okay, show IP. Gateway is 11.1.1.1. Let me see the configuration is okay on leaf 3. The leaf 2, sorry. Show run interface VLAN 11. Anycast is 11.1.1.1. Show BG. Actually, we can do show IP route VRF1. Show VXLAN. Let's look at the config. Show run interface VXLAN. Oh, I have not configured VXLAN interface. I'm missing some configuration. There you go. I stopped here, didn't I? This is also required. So that's why it's not properly working. Okay. My bad. Configuration mode and configure the VTEP. There you go. Now try this again. Let's first ping my default gateway. I can ping it. And now ping the other side if I can. 10.1.1.10, and it is working. So now I'm using VXLAN EVPN. I'm pinging from this PC all the way going to this. Now, as I said, when the traffic enters here, it is VLAN 11. But when it gets into this environment, this VXLAN EVPN environment, is it still called VLAN 11? Answer is no. So what will be the identity of this traffic in this fabric? Answer is VNI. So what is the VNI assigned to VLAN 11? This 1000011. You can check it actually. You can go to leaf 2. There you go. You can go to leaf 2. There's a command called show VXLAN VLAN to VNI mapping. And you can see VLAN 11 is called 1000011. The good thing about GNS3 is you can do packet capture very easily. So I'm going to do a packet capture on this interface, and then I will generate this ping traffic and capture it and look at inside. What do we see there? That should probably be the last thing I do on this in this lab. There are questions. No, Mohammed from Dubai, Fadi from Jordan. Welcome, guys. And now, so what I'm doing packet capture here, and I will generate traffic once again from this PC to this. So we can see it here. PC to. So I'm again pinging, and let's go to packet capture. Can you see this traffic coming from 11.1.1.1 PC2 to PC1, this traffic? Now let's look at this packet. Yeah, there is, I hope you can see this. This is big enough for you. There are multiple frames in it. This is search. I don't know how to zoom in here. No, yeah, we can. Okay. So you can see this packet from 11.1.1.10 to 10.1. There are multiple frames here. Can you see the VXLAN header here? This is the virtual extensible LAN. This is VXLAN. How do I know this is VXLAN? Can you see this destination port is 4789? So that is why we know this is Wireshark know this is VXLAN. If we look inside the VXLAN header, what is the network identifier here? Is it the VLAN identifier? Where is that gone? leaf 2. Is it the VLAN identifier? Answer is no. It is the VLAN. It is the IRB VLAN one. Why? Because this is layer 3 communication. This is communication between two VLANs. So remember I said whenever there is communication between two different VLANs, this is the VNI we will use. That is why we created this IRB VLAN. So for inter-VLAN communication, we can use its VNI. So VNI is 200,000. Okay, I wanted to do a bridging as well. I wanted to do an example of putting PC1 and PC2 into the same VLAN. And then if we do a communication, we will see the VNI of the VLAN. I have done it in a video that is on YouTube. If you don't know, there is a channel. I have a YouTube channel called youtube.com/love2network. I call it. So youtube.com love2network. And here you will find many videos. One of the videos here is exactly what I was doing today. Configuring VXLAN EVPN. This one. Yeah, this one. So here you will see I do multiple captures and show what I was trying to say here, but we don't have time to go in more detail. So with these remarks, I think I will quickly hand over to my colleague, Khoti, who's going to show you a demo of the automation. Any free demo setup and config tutorial online to try and practice, please. Drop an email to Mohit, and we will, I can share the same lab that I'm using today. I can share it with you guys in like a time sharing manner. So you'll get it for example, 4 hours, 8 hours, something like that. You can try it, and then we can use the same setup for someone else. So yeah, we can do that for you. Multicast. If I want multicast to work with SONiC, what are my options? I know one method is GRE encapsulation, but so if you want to use multicast, so multicast sparse mode, TOTI is supported, not in the VXLAN environment at the moment. In the VXLAN environment, potentially you can use GRE. You can potentially use GRE, yes. But you can potentially start with a simpler deployment, TOTI, without the multicast. Once we will support multicast with VXLAN hopefully in 2023. So by the time you've done your POC with the basic SONiC, it should be available. Okay, I will stop sharing now, and I will hand over to Toti to show you a quick demo of Ansible script configuring certain things on SONiC switches. So over to you, Koti.
Thank you, Cameron. Let me share my screen. And first of all, myself is Koti Sharao. I was running configuring data center switches or lab switches through Ansible automation. So let me give a small demo on how to configure the switch configuration through Ansible with a small, simple and simple playbook. So let me share my screen. Cameron, can you able to see my screen?
I can see your screen, yes.
Yes. How the Ansible server can configure the connect to the switch and how it can configure. So Ansible server is always connect the switch using a remote SSH. So where it can use a trust key authentication like key non-authentication keys and those based. So here the simple playbook. So if you want to configure any switch or a host name to the switch, so that we can do it, and we can do it one switch or as a bulk of switches in a one single playbook. Let me do one simple playbook for to configure a host name to the switch. So the Ansible playbooks based on, runs based on a inventory files. So here, if you can see my screen, there is a inventory underscore bc.yml, which I can use as an input for the host file to the playbook. That means where I can mention a switch name and IP. So based on this IP address only, switch Ansible server can connect the switch and it can push the configuration to particular switch. So if here you can see I have a 3 switches, but I need to configure only one switch at a time. I can limit that playbook to particular one switch.
Koti,
That
can you
also,
zoom in? Koti, can you zoom in a little bit? Thank you.
1 second. That's fine.
I think it's better. Yeah.
Yeah. So let me here now I can see, for example, I just log into one of the demo switch. Now you can see the switch name is BSS SW06. I want to change the switch host name. So for that I can just change the inventory file to the switch name 06 to 05. So after that I just save this and come out of the switch. Let's run a playbook. Let me show you that this was the host name change playbook. So what we are doing is config host name, the inventory host name. So here it need to push a switch name, what we need to set it up. So this inventory name is nothing but here what I have given in the inventory file. So the Ansible playbook take the input this name as an input inventory host name, and it will push to the switch.
Excellent. Excellent. Thank you, Koti. Any question on that? No? Okay. So these Ansible playbooks are available. Our friends from Dell has done a fantastic job. There's a GitHub repository there. They're also on the docs.ansible.com. You will see there are quite a lot of playbooks available for SONiC. Okay.
So
good.
Here I have 3 switches, but I was limiting to only this particular switch. The task. So if I limit a switch, one switch, it can push configuration to that particular switch. If I given this SONiC group, this is the group. If I given this SONiC group, it can push all 3 switches.
So same thing can be done for 1 switch or 100 switches or 1,000 switches, right? Yeah. Yeah. So very scalable, very scalable.
Yes.
Okay. And we use it at, Broadcom IT. Koti is from our colleague from Broadcom IT, where we have thousands of SONiC switches. And that's how we are managing them with automation, with Ansible, with all the DevOps tools.
So
okay.
you can see the output of this switch. So it was changed config hostname. It picked the hostname from the inventory file. So now if I log into the switch, there you go. The hostname is changed to 05.
Good.
So like this, we can do whatever the configurations we need, like VLAN configuration, some adding a trunk interfaces to that particular VLAN, and adding a untagged access interfaces to particular VLAN. Here is a one sample playbook. What I am explaining is, so the first command, what I have to do is need to configure one VLAN And after that, I need to add two interfaces, Ethernet 49 and 50 as a trunk interfaces to that particular VLAN. And after that, I have to set a speed to 1 gig, and I have to make it a shutdown and start up again that interface. So first what I do is I can remove this one here, startup. So now I was running this playbook. So it can push all the configurations, configuration to that particular switch. Ansible playbook. Here, -I inventory means what the inventory file I have to give an input to that playbook. That was the inventory file I was mentioning here. So hyphen limit to that particular switch. It is it's added a VLAN 1020, and the VLAN member ports for Ethernet 49, 50.
Change the speed.
Yeah, now I can go and check into the switch.
Good. Yeah, we're just over the time limit now, Koti, so maybe just show this last bit in.
Yes, 1 second. So see, I have created a 1020 VLAN, and that I have tagged 2 ports for that VLAN, and I have made a shutdown, right? So INT status, interface status. There you go. Ethernet 50 is a admin down.
Good. Yes, you can see that.
So all these things we can manage through Ansible nowadays. All our Broadcom DCs, fabric DCs.
Excellent.
So
Excellent.
and here is the syntax for the playbook. How we can write a playbook and all. Here we have it. So here I'm mentioning as a task name and with items what I need to push into the switches, what configuration need to push, and after that I was doing a config save. So this was the syntax for run a playbook. And if you need any more details about Ansible and playbooks related to SONiC, here is the reference link. You can just go through that link. You can get all the informations. And we can modify playbooks as per our requirement basis, our config changes and all. So if you have any questions, you can please about this playbook and all.
Good. Excellent. Thank you very much, Koti. Guys, if you have any question, please ask. I think otherwise we are reaching the end of the 3-day training. As Mohit said, we will share the presentations. Mohit will share the presentations with you guys, the lab guides that we had. And also, if some of you are interested in using the GNS3 server, that cloud lab that we have, share your interest with Mohit, and through Mohit, we will provide you the time slots and the details how to access it, and so you can kind of practice some of the new skills that you have learned. Are you back, Mohit? Okay. Thank you very much for listening in, guys. It's been a pleasure talking to you. It's been a pleasure delivering these trainings. It's a bit shame that we can't do it face to face. When it's remote, it's it's not as interactive, as human as a face-to-face one, but still, we see there are people from so many different locations. We were able to connect together and learn together from each other. I think it was awesome. So thank you very much for the opportunity to Distilogix, to Mohit and team, and thanks all for joining. Hopefully, you can continue your journey to learn more about SONiC and sharing this open source fun with your customers. If you have any questions, you can reach out to myself. You will see my email address and Sainath, Raj's email address, Koti's address when we share the presentations. So let's stay in touch and continue to spread the fun about open source and SONiC. Thank you. Have a nice day.